Okay, we are going to try and do some uh, transformations of periodic functions. We've graphed quadratics on here before. This is Desmos. There is a little bit of setup to graphing periodic functions. Everything looks nice here for a quadratic, but as soon as I type in y equals sine x, I've got some weird stuff going on, so I need to open up the graph settings. Now we need to, I haven't done this in a little bit, here we go. Right at the bottom here, we need to switch it to degrees. And now we almost can't really see what's going on. We can edit here. If we remember from that investigation that we did where we plugged in what was sine 90, sine 180, things like that. One period or one cycle of y equals sine x goes between 0 and 360. So let's go, minus 10 is fine. Let's go on the y-axis to 370 so we can see everything. So now we can see a whole nice sine curve here. And let's zoom in a little bit on the y-axis where we'll go from minus 5 to 5. So we've zoomed in. We could even zoom in on the y-axis a little bit, but I'm going to do some shifts coming up here. So there is my y equals sine x. Now all the shifts are almost the exact same as the quadratic, or as the quadratic shifts. So let me just move me down a little bit here. And I'm going to add another, there we go, and I'm going to add another sine function. Now remember, if we add something, y equals sine, and I'm just going to put the x in brackets for now. If we add something to the end, when we did that with a quadratic, when we added something to the end, it moved it up and down. Let's do the same thing here. Plus 2. This center line, the axis of our curve here, has just moved up 2. So this point that was at 0, 0 is now at 0, 2. It's shifted every point, every one of those key points. 90 and 1 is moved up. 90 and 3 it's moved up 2. Okay, that's our first one. That is our first type of shift. What I'm going to do now, remember inside the bracket for a quadratic, it was opposite of what we would think. So I'm going to do it opposite. This is over 90. That's a nice even number right here. So what I'm going to do is I'm going to put a minus 90. And what we notice is this point should be over 90. So it should be, if I click the top of this one, it should be at 180 now. There we go, 181. This starting point here was at 0. It should be over at 90. There it is, over at 90, the starting point. Now this is a little bit trickier for us to kind of visualize because this thing kind of keeps going forever, so it's also behind it if we were to extend it. But because it's periodic, right? So it's going to cross 0 a whole bunch of times. Here it is, not that exact same point, but there it is crossing 0 again. Now the last one is the trickiest transformation. Actually, no, we don't have to do the trickiest one. So that's for grade 12. So let's just do, this one is called, actually that one we're not having to do. This one is called an amplitude change. So if I put a 2 in front here, notice what happens. I go from 0 to 1 to 0 to minus 1 to 0. Nothing changes in how long the period of this is, or the cycle length there. But the amplitude changes. So instead of going up to 1, just because there's a 2 there, now we go up to 2. And we go down to -2. Those are the different shifts, so we can move it left, right, up, down, things like that. And in grade 12, we're going to change this period or this shift. And it kind of works opposite too. This is a little bit extra. If I put a 2 here, notice what happens. Here is the sine curve. There is one of them between 0 and 360. Now, here is one complete cycle. Here's another complete cycle. So there are 2 complete cycles because of that 2. Normally when we affect right at the x, we think of the opposite. So we would, if you want to think the opposite, and this is where it gets a little bit confusing too, is this one is half the period. So a regular period is 360. Now one period is 180. So 2 of them fit within the same one. If we did 3, it'd be 1/3 the size, and 3 periods fit within one of the regular ones. Anyways, those are all the transformations. There's a couple investigations there. If you didn't quite get it, play around on Desmos and ask any questions if you have any questions.